Okay. Um, so, um, yeah, I'm sorry I've had to go to Zoom this week. But there isn't any other way to handle things. Also, next on Thursday, I have to pick one of my daughters up at 5. I should be back here at 5:20, but if you join and there's no one there, that will be why. I might be a little bit late. All right. Um, So the reading for today is three direct critics of Popper. And I say direct because, I mean, I'm going to read Kuhn basically as a kind of um, response to Popper, but Kuhn barely mentions Popper. So you have to read between the lines. Some of these people mention Kuhn, as you probably noticed if you read it. But um, and so in some ways, all three of these people are very different from each other. Um, I guess I'll write their names down on the whiteboard. Right, one that we've seen before is Otto Neurath. 1882 to 1945. Oops. Um, Hilary Putnam, who was a member of my dissertation committee, so I knew him pretty well. Um, 1926 to 2016. Um, and finally, Imre Lakatos. This probably really needs some accents, but 1922, 1974. And so Lakatos died in 1974, which is also the year in which the Popper Shilp volume that both of these are taken from was published. So that's, you may have noticed there's a note saying that Professor Lakatos died before it was published. Um, so whereas Hillary Putnam lived on for another 34 years or whatever, 32 years. Um, so, whereas Neurath's paper that we read is from 1935. So these are from like actually pretty distinct eras of response to Popper, and there are some big differences between them. But so I'll talk about some of the differences first, but I'm mostly going to talk about the things they have in common because they actually have a lot in common. Um, so that is, there's a kind of common response to Popper here. Um, so, I mean, they're different. So, I mean, there's a lot of details that are different, obviously. Um, but they're different, I think, most strikingly in their attitude towards Popper, like what their relationship to Popper is. So, I mean, they all begin with kind of respectful remarks. Um, but Neurath gets pretty quickly to the moral that Popper is not one of us. Be careful, right? That's pretty much the tone of this. Like, notice how much respect he has for the bad old kind of philosophy. Um, um, and Neurath says, yeah, he did use some ideas that were developed by us. And there's some isolated lessons we could learn from him, but basically, be careful. Um, Putnam, so first of all, Putnam uh, was I don't know if it's right to say he was a student of Carnap. He certainly met Carnap and talked to him. I think I told you this one story that Putnam told me about Carnap before. Or it wasn't really a story. It was like, although I don't know how many times it happened, but Putnam said this always happened when he talked to him, that he would, he would say blah, 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 blah. And Carnap, who had a very deep voice, would say, "Oh, so you think," and then he would say something that both obviously followed from what you just said and was obviously absurd. And like Putnam, certainly when I knew him, but I think probably even less in those days, Putnam was not easily intimidated. Um, he was, um, so it so happens that my father knew someone who was in high school with him, with Putnam. And he told him, "Oh, my son's taking a course with Hillary Putnam," or I don't know how it came up. And he said, "Oh, you mean sit down Hillary?" So apparently in high school, his nickname was Sit Down Hillary because he would get up and start arguing with the teacher, and the teacher would be like, "Sit down, Hillary." So, yeah. Now, I mean, when I knew him, he also had this, in his later years, he developed this kind of soft side. So, like when he talked about, uh, like Buber or Rosenzweig or Levinas that he got interested in, all of a sudden he would get a soft voice and he would, but like if you got him back to talking about set theory or something, it would be the old like harsh Putnam would come back. It was like bifurcated. Um, but so anyway, Putnam was not someone who was easily intimidated, but he clearly found Carnap very intimidating. I think he was more a student of Quine. Um, anyway, he was definitely kind of from that side of things. So I think that he actually inherits a little bit of Neurath's hostility to Popper. Actually, another story, this is a story about me that I once met Putnam, walking down the hall, and he said, "Oh, what are you reading these days?" And I said, "Well, actually, I've been reading some Popper." And he was like, "No, no, 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 no." So, now that was a long time after 1974. That was sometime in the 90s. Um, but yeah, in any case, so his relationship to him is uh, not very respectful, despite the opening paragraph where he calls him Sir Carl and whatever. Um, he kind of likes that Popper is at least on the right side, that is Putnam's side of certain arguments. Um, in particular, he likes Popper's realism. Now, I mean, actually, you can't, the realism thing doesn't come out so much in the logic of scientific discovery. It's something that Popper is more explicit about later on after Tarski uh, persuades him that it's okay to talk about truth. Um, but but nevertheless, Neurath in 1935 smells it, and like at the end, like his big charge against Popper is, he's really one of these metaphysical realists. And that's exactly what Putnam says is great about him. Yeah, he's a realist, like he should be. Um, uh, but I think um, for the most part, actually, um, he kind of classes them together with his teachers like Carnap and Quine, or especially, well, both, I guess. Um, they're just all part of the same old generation that they're involved in these intricate theoretical disputes, and meanwhile they're totally out of touch with what actually is happening and like how science actually works. Um, and what we might actually need to do to change the world. Um, and Popper is actually worse because Popper's thought is quote unquote reactionary. That is, he's against Marxism. Um, And remember, I think I also told you this about Putnam that uh, at this time, well, I don't know exactly where he was by 1974, but I mean, I've heard that in the 60s he was, so he was a Maoist and he went everywhere dressed in black pajamas and he used to like stand in Harvard Square giving out literature and stuff. Um, so, um, so in a way, this is Putnam's reaction to Neurath and Carnap and Popper is kind of like the reaction of the young new left of the 60s to the older generations of leftists and liberals, right? Like Popper was a liberal, and Carnap was a socialist, and Neurath was a Marxist, but like from Putnam's point of view, they're all just out of touch. They never achieved anything, really. I mean, so he's not, for the most part, he's not, although some, at one point politics comes up explicitly, but for the most part, he's not talking about that directly. But as I think we've seen this before, there's like a tight connection somehow between your views about philosophy of science and your political views. Um, so, um, so given all that, I think the tone of Popper's reply to Putnam is somewhat justified. Now, I didn't have you read the replies, but remember, as I think I explained in this series, um, the Library of Living Philosophers, they had people write things for it. So they had Putnam and Lakatos and a whole bunch of other people write things for it, including Carnap and whatever. And then Popper replies. So you can read about Popper's response to all of these. Um, and his response to Putnam's starts like this. Uh, I enjoyed reading, actually, I can screen share and show it to you probably. Why not? This is the wrong thing, but I should be able to find the right thing. Wrong page, but I should be able to find the right page. Here it goes. I enjoyed reading Professor Hilary Putnam's paper because it is crisply and clearly written. But Professor Putnam's conclusions are all wrong. Professor Putnam is a leader of the younger generation of logicians, while I am a tottering old metaphysician. This is perhaps the explanation why he found it unnecessary to do his homework. And then on the next page, he says, but in general, he has not read, or if read, not understood what I have written, some of which happens to be very similar to, but older than, a very interesting paper of Putnam's to which he refers in his footnote. Right? This Popper is saying, I happen to have written something very similar to what Putnam writes in his paper, but mine was older. That is, I wrote it first, and Putnam didn't even know about it. Um, so that's Putnam and Popper. And as for Lakatos, so Lakatos is like sees himself as Popper's disciple. Um, right? He says Popper was my inspiration. Popper changed my life. Um, and I'm trying to continue Popper's, let me stop this share now. I'm trying to continue Popper's research program. So research program is one of Lakatos's own technical terms, right? Probably what he's most famous for is the theory of research programs. And another thing that he also mentions here, problem shift. Um, and he applies these are part of his apparatus for understanding science, but he applies them also to his relationship to Popper. right? So he says, I'm trying to continue his research program, but I've instituted a problem shift, so I've changed the question slightly that we're trying to answer. Um, and therefore, the question Lakatos asks, under what conditions would you give up your demarcation criterion, right, aimed at Popper? It's actually a rather poignant question coming from Lakatos, right? Like he's saying, like, under what conditions would you accept what I'm doing? It doesn't mean under what conditions would you give up your demarcation criterion and become an inductivist or something like that. He means under what conditions, that's not what he's thinking. He's thinking like under what conditions would you allow that I might continue your research program differently? And Popper's response um, to Lakatos, therefore, is somewhat less justified in tone, I would say. Um, so again, I'll show you how it starts. Um, this is page 1000. So Popper starts by saying that Lakatos has been publishing stuff about him for many years and that he's mostly avoided reading it. And he says, now that I am called on to reply to his views, I am disturbed to find that the argument which appears to be crucial for his criticism of my views on demarcation must, in my opinion, be rejected as totally unsound. That among his criticisms, he raises points which I had not expected from one who is well acquainted with my work, and his examination of my views seems to have left him, and unfortunately, a large number of people who have read his papers, with an interpretation of my theory of falsifiability that makes nonsense of all my views. So he could have been nicer. Admittedly, Lakatos was already dead when it was published, so maybe it doesn't matter. But I think um, from everything I've heard, Popper was not really a very nice person, actually. Um, so, uh, all right. So they're coming from rather different points of view. Um, However, as I said, there's some common themes, and I'm mostly going to discuss the common themes. Now, I mean, they do also all have in common that they misread Popper in a certain sense, or at least, um, well, so I mean, I think Lakatos is most explicit about this. Lakatos says, "I've tried for years to understand what Popper really means. It's not easy." Um, and I think that's accurate, but I think also um, there's some systematic misreading, even in Lakatos, or at least presentation of Popper's view in ways that encourages misreading. Um, because, like, if you're going to criticize someone, uh, in philosophy at least, um, maybe I guess not in other areas of life, but in philosophy, if you're going to criticize someone, you want to build them up as much as you can, right? Like you want to make sure they have their best argument before you start attacking it. Um, Whereas it's common for critics of Popper to kind of like wave away all the complicated defenses that Popper has. And even Lakatos, who knows all that stuff, still when for example, Lakatos talking about him keeps saying that um, a single falsification leads you to reject the theory, which, as we know, is not what Popper says. So, um, um, I mean, I think Lakatos just means, yeah, okay, it's not just it's a falsifying hypothesis. Um, And in fact, when Lakatos brings an example, it is a falsifying hypothesis, as I'll talk about. It's not just a stray observation, but he presents it in such a way that you could miss that. Um, and yeah, there's an extreme instance of this that Popper mentions that I think I might have also mentioned before when I was introducing Popper. Um, this is on page 984. As Professor Ayer writes, he's talking about A.J. Ayer. I'm not sure. I should have written down what this is part of the response to. Anyway, I don't think this is a response to Ayer. I think it's a response to someone else. But as Professor Ayer blames me because I quote, found it necessary to modify in the manner described here my principle of falsibility in the course of this very book, Logik der Forschung. In fact, in the course of its very first chapter, see the penultimate paragraph of its section 6. I gladly accept the blame. It turned out to be more fertile than sticking dogmatically for years to a long ago refuted sterile criterion of meaningfulness. He's saying, yeah, I'm willing to admit I rejected a simplistic version of falsifiability in the very book. In fact, in the first chapter. And unlike Professor Ayer, who admirably stuck to a sterile criterion of meaningless for his whole life. All right. So, uh, right. I mean, that's an extreme example because I say, like, people, like, they're fixated on a simple version of Popper. And even if in the very first chapter, when he's first introducing his view, he says, no, don't understand it that simply, they already see that as kind of like, oh, yeah, yeah, he has kind of raised his hands in defense, but we know what he really means, right? Um, um, so, I mean, so I think it's fair to say that they do, even Lakatos, they all misread Popper in certain ways. And it's certainly true that Putnam um, appears not to be aware of everything that's in Popper's book. However, Popper's responses, I mean, that is his actual responses to Putnam and Lakatos, and at least the way you might imagine him responding to Neurath. I don't think he ever did respond to this directly, but the way that his actual responses are also misreadings of his critics. Um, and he responds by pointing out how they've misread him. But I actually said X, right? And it's true, they should have said that he said X, but they actually do raise real issues for him, I think. So it's kind of like obscured by the fact that in some ways they're unfair to him. So again, like on his side, I could say the same thing. Like before he starts attacking them, he should have tried to say, okay, they don't understand, they haven't read my book properly. They missed certain things that I said, but is there a real problem here? Rather than just like dismissing them right away because, which I mean, I can understand would be tempting, right? If someone writes a criticism for the volume on, if there were a volume, which of course there never will be, if there were a volume of Abe Stone, Living Philosopher, and someone responded to me, and in the very first paragraph, I could tell that they hadn't read the relevant thing, I would be tempted to just dismiss it, I think, obviously. So, I mean, it's understandable, but it's still unfortunate because, we have to try to figure out whether there really is a serious criticism here. Um, so one thing they all say about Popper is that he wants too much logical purity, right? He wants clean distinctions. He wants definite decisions in advance about what a theory says. Um, all these people actually charge Carnap with the same thing. So again, this is maybe a generational issue or something. Neurath and Putnam charge Carnap with the same thing in other places um, by name. So, I mean, like we read Neurath saying this about Carnap. Um, um, Putnam, uh, if we'd had one more uh, class meeting, which we didn't because of Veterans Day, we would have read a paper by Putnam where he says this about Carnap. So, and as for Lakatos, he was much less interested in Carnap. His main he's like a Popperian, right? So his main interest is in Popper, but he does mention that both inductivists and Popper have failed to notice certain things. And I think I think all of these people believe that both Carnap and Popper have failed to pay attention to a certain messiness in the way science develops. Um, for example, that science progresses sometimes in part precisely by failing to keep careful track of the meaning of its terms or of its theories or of its questions. Um, um, Allowing the theory or the research program to change in a way that keeps it going when the old version wouldn't work, right? So this is what Neurath um, has in mind when he talks about quaternio terminorum, right? The uh, fourness of terms. I think I mentioned this before, right? Quaternio terminorum means um, in a classical Aristotelian syllogism, there are three terms, right? So like the first premise is all A is B, and the second premise is um, all B is C, and the conclusion is all A is C. So this is called the middle term, right? The one that occurs twice. There's three terms, right? So it's like all humans are mortal. Socrates that is all Socrates, right? Socrates is no, wait. I've got them in the wrong order. It doesn't matter. All right. Um, oops. And now my fun's easel is falling apart again. What a day. All right. No, no, no. Come back. Uh, there we go. Right? So like all humans are mortal. Socrates is a human, therefore Socrates is mortal. So there have to be exactly three terms. Quaternio terminorum means that instead of being three terms, there are four terms because although you use so and at least this is how it's supposed to happen. Although you use the same word for here and here, you used it in different senses. It was equivocal. So the first premise was true only in one sense of B, and the second premise was true only in another sense of B, and therefore the conclusion doesn't follow. That's the fallacy of quaternio terminorum. And Neurath says that science often progresses by a kind of quaternio terminorum, meaning that like it changes the meaning of the term in the middle of the argument. So, like, well, I think I mentioned this before when I talked about Neurath, that, for example, the meaning of the term momentum changes between Newtonian physics and special relativity, and this allows you to keep the statement that momentum is conserved, even though it doesn't mean the same thing anymore. Yeah, we have a reasonable unfalsified supposition that the boss is a bastard. Right. Although the truth is, well, I guess this is actually a kind of ambivalence in Marx himself that, because on the one hand, he says it has nothing to do with the personality of the individual capitalists, right? Like it's not that they're bad people or good people, and in fact, the way we distinguish good and bad is itself just a superstructure of capitalism, right? So it's kind of irrelevant. And yet, on the other hand, um, you can tell how very angry he is at the capitalists as he discusses labor practices in Britain and whatever, right? So, yeah, the boss is a bastard is like strictly speaking should is not like shouldn't be part of the explanation of why we're in trouble. Um, and as for climate change, yeah, I mean, it's worth remembering that Chernobyl was publicly owned, right? It was not a capitalist enterprise. Um, it's not
My
it's not clear that that's relevant. But I'm sorry, I'm
my
getting way
point
off
is
topic and bringing my own political opinions in here, which is probably bad. All right, let me go back to um, um, right. So this is how Lakatos, I mean, sorry, this is how Neurath says it, the Quaternio Terminorum. Um, Lakatos is making a similar point when he talks about problem shifts within research programs, right? The problem shift is a way that um, the the research program can continue its research uninterrupted, even though uh, it wasn't able to answer the original question by kind of changing it to a different question midstream. So it's also, I mean, it doesn't, he's not focusing necessarily on ambiguity of terms the way Neurath is, but it's the same type of idea. It's not like Popper says, you have to decide to begin with what you're um, staking yourself on. This is my theory. This is how it can be refuted. And then you're not allowed to change it. That would be against the rules, right? Whereas Lakatos is saying, well, actually, no, that's not what you do. That's not what scientists actually do. So, I mean, again, there's something similar both in that Neurath and Lakatos both point to this kind of messiness, and that they point to the messiness by looking at what at least they claim scientists actually do. Um, okay. Sorry. I'm sorry. Josephine clarified that she wasn't blaming. Right. All right. Doesn't matter. Okay. Back to this. So, Putnam doesn't bring this. I mean, he definitely does say that science is messier or more complicated than Popper thinks, but he's actually there's a famous paper by Putnam called "The Meaning of Meaning," right, where the second meaning is in quotes. So it means the meaning of the word meaning, um, where he um, This is a little bit different from Neurath. So Neurath like is admitting that the meaning of the word changes. And that makes it logically invalid, but we go on anyway. Um, Putnam says that's not what we call meaning, essentially. That's why the paper is called The Meaning of Meaning, right? He says, like, the meaning of the word water hasn't changed, even though we used to think it was one kind of thing and now we think it's something else. It always meant the same thing, namely water, right? We just didn't know that water was H2O before. Um, so, uh, So, okay, sure enough, the meaning of water or electron or whatever maybe hasn't really changed, if that's what you mean by meaning. Uh, but it still has the same effect in terms of like the things would that would previously have falsified your theory now won't, even though the theory has the same words, right? So, um, uh, So, okay, that's a point that they all make. And I think moreover that Neurath talking about um, encyclopedias is doing something similar to what Lakatos is doing when he talks about research programs instead of theories. Right? The encyclopedia is not a single well-defined axiomatized theory. It's not even close to it. And that's what Lakatos says about the research program too. I mean, there's some differences between the way they look at it. Uh, but I don't think Neurath emphasizes that the encyclopedia has a core that we're not willing to give up and has other parts that are more superfluous, which that's what's essential to Lakatos's notion of a research program. But they do both emphasize that it's a big conglomeration of stuff and it's not all tied together the way Popper thinks an axiomatized theory ideally should be. And again, like the reason Popper wanted that is because he wanted to make it clear what you're committing yourself to with what part of your theory and what will falsify what. And once instead you have a whole encyclopedia or a complicated research program, then it's all those things become unclear. Um, so that's kind of a segue. This first thing they have all have in common, namely they're pointing out that science doesn't, or at least claiming that science doesn't make these clean-cut predictions and descriptions and axiomatizations and definitions the way Popper wants. Um, is it's partly of a consequence. It's partly a consequence of that we don't, they all say, just abandon theories because they've been shaken, as Neurath puts it. Um, and uh, Putnam and Lakatos, there's an example that both Putnam and Lakatos bring up. And it's worth discussing. I don't think I've discussed this yet in this class, or I might have mentioned it briefly, but I don't think I said exactly what it is. The anomalous precession of the aphelion of Mercury. So, right, so like according to Newtonian mechanics, if you have two point masses and nothing else in the whole universe, then their orbits will be a conic section around the center of mass. So like if this is the sun and this is Mercury, so the center of mass will be much closer to the sun than to Mercury. Is this visible or is it out of focus? It looks out of focus.
I don't know. It seems visible to me.
Okay, all right, I'll leave it then. All right, so the center of mass is much closer to the sun than it is to Mercury. In fact, in real life, the center of mass of the sun-Mercury system is inside the sun. Okay? But here we're assuming the sun is a point mass. So anyway, so they each go in circular orbits around, I mean, in conic section orbits around the center of mass. So maybe this is the sun's orbit and this is Mercury's orbit. Now, Mercury's orbit is not, and when I say around, it means The center of mass is a focus of the conic section. Now, Mercury's orbit is not is much closer to circular than what I'm drawing, and well, it's not at all the shape I'm drawing. It's an ellipse, but it's very close to being a circle. But anyway, so it's an ellipse, so it has a um, oh, I guess perihelion is what they usually say, although it's both. It has a perihelion and an aphelion, right? That is, has a place where it's closest to the sun and where it's farthest from the sun. So if Newtonian mechanics were right, and these were both point masses, and there was nothing else in the universe, these conic section orbits are closed. So Mercury will always come back to the same place over and over, and that will go on forever. So in real life, the orbits of the planets don't do this. And Newton started explaining very early why it is they don't do it, because there are other masses. Also because they're not point masses, so that they lose energy to tidal forces, basically. Um, but that's probably less important here since Mercury doesn't really have an atmosphere or anything. But so anyway, the orbits are not perfect conic sections. They differ in various ways, and one way they differ is that this line um, precesses. So rather than next orbit coming back to the exact same place, Mercury will come back to a slightly different, will come closest to the sun again at a slightly different place. And so the orbit overall is a kind of like rosette, right? Like it, I can't really draw it, but it's it's major axis precesses around the sun as time goes on, and that can be so like all the planets I guess have this, and it mostly can be explained by the effects of the other planets, right? So like if Jupiter is out here, Jupiter is also exerting gravitational forces on Mercury. They're much weaker than the force from the sun, but they're enough to change the orbit a little bit, and this is one of the ways they change it. And Newton and successors were able to explain most of the uh, perturbations in the orbits of the planets, right? These like deviations from the conic section are called perturbations. They were able to explain most of them, but they were only able to explain part of the precession of the perihelion of Mercury. Part of it was unexplained. So that's the anomalous precession. And so Putnam and Lakatos both mentioned this example. What's important about it, first of all, is that it's not a stray observation, it's a falsifying hypothesis, right? It goes on, everyone can observe it. It goes on for centuries. Mercury never behaves the way it's supposed to. Um, People tried, even this is already questionable from Popper's point of view, people tried various ad hoc hypotheses to try to explain it, right? At one point, it was suggested that there was a planet inside the orbit of Mercury that they called Vulcan that was responsible for these perturbations, but there is no such planet. So it was an unexplained anomaly. And yet, Newtonian mechanics wasn't abandoned. When was it abandoned? Well, it was abandoned when we had another theory, general relativity. General relativity was not adopted in order to explain this, though. It was adopted for other reasons. Kind of weird, like rationalistic reasons. I think someone was mentioning this about Einstein before, right? So, in any case, it wasn't adopted in order to explain this. However, it turned out right? And you see this with Mercury because it's closest to the sun. And so the gravitational field is strongest there, of the sun is strongest there. And it's strong enough that Newtonian mechanics needs to be corrected to give the right prediction, right? So when you make the, the like lowest order general relativistic corrections, the anomalous precession comes right out. That explains it. Um, so, so what? It looks like the scientists for a long time ignored um, a phenomenon that really did show that their theory was wrong, as it turns out, right? Like, as we now know, this really was a sign that Newtonian gravitation is not right. They ignored it. They said, we don't know what the explanation for this is. They tried a couple ad hoc things, but they mostly just said, yeah, we don't know what to do with this. Um, and yet it seems like that was the right thing to do, right? Because general relativity, there's no way someone would have come up with general relativity in the 19th century. So um, they would have had to say, well, okay, Newtonian mechanics seemed like it was really good. It explains all the orbits of all the other planets. It almost explains the orbit of Mercury, but it doesn't explain this one stubborn effect. So I guess we should give it up and just guess where the planets are going to be or something like that, right? And that seems like it would have been clearly the wrong decision, right? So that's why Lakatos and Putnam are both focusing on this example. Um, and I mean, this is also going to be an important example and an important point for Kuhn. Um, and notice that Putnam and Lakatos both mention Kuhn, right? So like this is 1974 is actually after um, I think the Structure of Scientific Revolutions is actually published in 1962 or something. It's quite a while after. Um, they're already aware of Kuhn's point of view on this, but I don't think either of them take the strong moral from Kuhn that you should. And I think, Kuhn is going to have a much more radical interpretation of why this happens. But for Putnam and Lakatos, it's just a sign that, um, yeah, we try to falsify theories, but we don't just give up a theory when it's falsified. We stick with it until we have something better, or something like that. In fact, Neurath and Lakatos both make clear, Putnam doesn't mention this, at least not in this paper, but I feel like he would agree with it. Um, we don't even abandon the theories when they're inconsistent, right? So that they don't make any predictions, or they make all predictions, or something, right? Anyway, they're not usable as oh, it's saying my internet connection is unstable. Oh, I know why. It's because someone's running the microwave. Hopefully it's short term. All right. I just got a warning that my internet connection is unstable. It'll be fine because it's radio. All right. Anyway, sorry, back to this. Um, so um, I mean that's part of the point about encyclopedias, right? Like an encyclopedia can contain different articles that actually contradict each other. And yet it can still be worthwhile as an encyclopedia. It can still be usable as an encyclopedia. Um, and Lakatos thinks the same thing about research programs. They can have parts that are not really consistent with each other. Um, Lakatos actually mentions, so he quotes Popper as saying, Frege didn't try to defend his theory when Russell found an inconsistency in it. He just gave it up right away. Now that's talking about a mathematical theory, not an empirical scientific theory, but actually one of Lakatos's projects was to expand this discussion of philosophy of science to include mathematics as well. Um, So, yeah, Popper says Frege didn't try like various tricky things to defend his view. Once Russell found an inconsistency, he just gave it up. And Lakatos says, well, of course, Frege did try that. See, so and so, right? That was Frege's first reaction. Oh, Terry said I was breaking up. Am I back to normal now that the microwave is off? Okay. Yeah, it was the microwave. Um, so Josephine says, so would Popper say this is a form of conventionalism from Neurath? Wait, which? The thing
The
about
bit
not,
about the bit about like adjusting your terms following Quaternia Terminorum to like keep a theory because it's a little bit falsified, but it's the one you've got, and so you just have to adjust it, and so it keeps working.
yeah, yeah. Would, well, I think the right way to put it, and I think this is what Lakatos says at some point, is that Popper doesn't have anything to say about this except in his discussion of conventionalism. But conventionalism is an extreme case, right? Clearly, scientists don't do that, right? They don't like, they mostly don't. That was something certain philosophers proposed, basically. But scientists don't mostly go around saying, you know, well, the definition of lead is that it melts at such and such a temperature. So if we find that what we used to call lead doesn't melt at exactly that temperature, it's not lead. Right? Like that's that, Um, but so they don't do that. They don't do that extreme thing, and that's the only case that Popper discusses. But they do something else that is kind of like in between the clear cut uh, um, falsificationism that Popper demands and a clear cut consistent conventionalism. Right? So remember, Popper says, yeah, conventionalism is perfectly consistent. You can do it if you want, but you shouldn't. Right? Whereas I think Neurath and Lakatos and Putnam are all saying what scientists actually do is um, um, not really consistent. It doesn't obey these like strict logical rules one way or the other. Sometimes they will give up a theory because of it, because it's been falsified. Other times they won't. Sometimes they'll change the theory. Sometimes they'll doubt the observations. Sometimes, there isn't as Putnam says, there isn't an algorithm that will do this. Um, Now, I mean, Popper responds to that. I think I mentioned this before. He responds, first of all, by saying that the word really should be algorithm, not algorithm, because it's named after some guy. um, I forget what his name is, but some Arabic guy who it's named after. Um, so anyway, but that's not to the point. But he also says, I never said there was an algorithm. And it's true, he never said there was an algorithm, right? So again, Putnam, in implying that he did think that, is being unfair to Popper. Popper makes it clear that in the end, um, methodology leaves us in many cases having to guess what to do next. Right? It doesn't give us step-by-step mechanical instructions for how to advance science. However, it's also true that Popper um, uh, demands that your theory be logically, well, I mean, even in this case, he says this is an ideal we never completely reach. but he demands that your theory, as much as possible, be logically distinct and coherent, and that um, you uh, um, not change any of your bets in the middle of the game, right? So, um, um, whereas Putnam is saying, but scientists do all of that stuff, and they don't have a consistent story about when. They just don't use theories of the kind that you're thinking about. Um, it's relevant also to the story I mentioned before about that Carnap mentions in his intellectual autobiography that he told a physicist at Princeton. And again, I always wonder if this could have been Einstein himself. But anyway, he told a physicist at Princeton that he was working on axiomatizing general relativity. And the physicist said, in physics, there are no axioms, right? Which is true. I mean, if you open a physics textbook, you will not find axioms and definitions at the beginning. Physicists don't use math that way. They use it constantly, but not that way. Not the way mathematicians do. All right. So anyway, um, so that's another thing they have in common. We don't abandon theories just because they're shaken. And moreover, we don't do it unless we have another one on hand. We never do it. Although Putnam says, well, sometimes we might, if things get bad enough, right? If the world, as he puts it, starts to behave in a markedly non-Newtonian way, maybe even without an alternate theory, we would have given it up. So as you know, as Popper says, like, yeah, if the force of gravitation suddenly became repulsive instead of attractive, you would notice that right away, and you wouldn't need any special like initial conditions or whatever to realize that this was non-Newtonian behavior. Um, so yeah, Putnam allows that might sometimes happen, but or it could have happened. I'm not sure if he thinks it's ever actually happened, right? This is again a kind of empirical catastrophe, which as a matter of fact never happens so far, right? We don't wake up and suddenly find that the force that was always attractive before is now always repulsive. Um, and we don't really believe that will ever happen in the future either. That is, I think Popper would say it's psychologically impossible for us to believe that that might really happen, however much we might say it. We're not going to act on that. Um, Josephine says, I hope that happens. Yeah, that would be bad. Um, all right. What would happen? This would be like a question they would have asked me on my qualifying exams when I was trying and failing to become an astrophysicist. Uh, what would happen? What would happen first? The sun would explode? I don't know. Anyway, it wouldn't be good. Right. So, um, and even when we do have a new theory on hand, they all agree we don't do it hastily. There are no crucial experiments. Right? I think actually all three of them mention this, that there are no crucial experiments except perhaps after the fact. We'll see Kuhn saying the same thing, right? A crucial experiment looks like a crucial experiment after the new theory has been adopted. Then you go back and say, like the Michelson-Morley experiments in the case of special relativity, you know, they tried to measure the Earth's motion relative to the luminiferous ether by seeing that the speed of light was not the same in different directions, right? So like if um, like if you're moving through the air, and you measure the speed of sound in different directions, you would see that sound is faster in that direction than it is in this direction. Right? I mean, you're moving this way. So you're moving this way. So you're like coming to meet the sound, so it comes to you faster. Right? Um, so the before uh, special relativity, the thought was that light was like this too, only the medium is not the air, but the luminiferous ether. And so, since the Earth presumably is moving through the luminiferous ether, right? I mean, it can't always be at rest with respect to it because it's accelerating. It's moving in a circle. So it has to always, whatever the luminiferous ether is doing, the Earth is sometimes moving relative to it. So they, Michelson and Morley set up this experiment to measure that ether drift by measuring the speed of light in different directions. And they got a negative result. The same speed of light is the same in all directions. At that time, was that a crucial experiment between um, Maxwellian electrodynamic? Well, actually, anyway, between classical electromagnetism and special relativity, um, no, because um, um, people weren't at the point of deciding between classical electromagnetism and special relativity. After the fact, we point to it and say, look, this was the first clear experiment. This showed that there's no classical explanation of how light propagates. Um, um, so, um, Popper's response about falsifying hypotheses clearly doesn't. Um, that is, if Popper says, "Look, I never said we gave up a theory every time there's a falsifying observation," it's true, he never said that, but that's not what we're talking about here. We're talking about measurable, observable, replicable effects that nevertheless are ignored or at least not acted on quickly. Um, um, oh, I guess actually, when I wrote that in my notes, I meant something else. Popper can respond by saying, "Oh, I also agree that we don't give up a theory unless we have another one rating. That is, we have to have a falsifying hypothesis. That's another theory that we have waiting. I always said that. But that falsifying hypothesis is not uh, it can be a very low level generalization, not a universal theory of the kind Popper thinks we need, right? It can just be there's a family of white ravens living in the zoo in New York. Um, Now, in his replies, um, this is in Popper's replies, and he claims that this was his view all along, even in the logic of scientific discovery. But I was yet a little more self-critical in Logik der Forschung. I first noticed that such a rule of method is necessarily somewhat vague, as is the problem of demarcation altogether. That's not very clear in Logik der Forschung, but anyway. Clearly, one can say that if you avoid falsification at any price, you give up empirical science in my sense. But I found that in addition, supersensitivity with respect to refuting criticism was just as dangerous. There is a legitimate place for dogmatism, though a very limited place. I don't remember a place where he says that in Logic of Scientific Discovery. But he claims that's what he thought even back then. He who gives up his theory too easily in the face of apparent refutations will never discover the possibilities inherent in his theory. There is room in science for debate, for attack, and therefore also for defense. And at the end of the paragraph, as always, science is conjecture. You have to conjecture when to stop defending a favorite theory and when to try a new one, right? That is, we must guess. So whether or not that was really something he already said in the Logic of Scientific Discovery, I think we can gather that's Popper's response to this in 1974. Um, Unfortunately, he doesn't cite a page number here in Logic of Scientific Discovery, so I don't even know which discussion he's thinking implies this. Maybe the one about conventionalist stratagems. Um, but in any case, right, so his position in 1974 is, yeah, sure enough, uh, um, even if that's a falsifying hypothesis, it's not always a good idea to give up the theory. Um, Sometimes, and then what is he admitting you're allowed to do? I mean, surely not quaternio terminorum, like change your definitions. Maybe he's even admitting you can do that, but I guess he's admitting you can let in an ad hoc hypothesis. Right, an ad hoc hypothesis, there's some discussion that's in Lakatos, but from Popper's point of view, an ad hoc hypothesis is basically a hypothesis that doesn't improve the predictive or the falsifiability of the theory. So that is, it explains away the falsification, but it doesn't add more predictions which now could be falsified. Um, um, Such as if I were to say, I explain the perturbations in the orbit of Mercury by saying that there's an unobservable mass that's making the perturbations. You can never see it. Even that would make more predictions, though, because eventually it would perturb the orbits of the other planets. I don't know. It's hard to think of a hypothesis that's completely ad hoc in this sense. um, but and does he allow that even you can just ignore the falsifying hypothesis? You can just say, oh, well, who knows why that's happening. But anyway, it's too hard for us to figure out. We'll go on to something else. If he does, then he's gone a long way in the direction of Lakatos, I think, especially because he's closer to Lakatos to begin with. Um, Now, there's another thing they all mention that's a little bit harder to, but I think that Putnam especially emphasizes this a little bit harder to deal with. And for this, Putnam uses, and I think maybe all three of them also mention this example, the discovery of Neptune. Right, so the discovery of Neptune is also about unexplained perturbations, but in this case, they were able to find the explanation, unlike in the case of Mercury. So, Uranus or Uranus. So Uranus. Uh, Also, in this case, I'm not sure what the perturbations were, but they were unexplained perturbations in the orbit of Uranus. And so two people, I think independently, sat down to calculate um, whether an undiscovered planet could explain these. Um, And they both found that, yes, if there's a specific orbit, that if you put a planet of the right mass in that orbit, it will explain these perturbations. And so they said to the observatory at Berlin, like, look in the sky in this direction at this time, and we predict you'll see a planet. And sure enough, they turn the telescope in that direction, and there's Neptune. Right? So again, this is one of the great success stories of science. And yet, something funny seems to be going on here from a Popperian point of view. This is where Putnam introduces this thing that he calls schema 2. Right? Schema 1 is theory, auxiliary statements, and and from those we derive a predicted observation. I guess I should say prediction. And then you can check to see if the prediction is true or false. And that's the scheme that Popper is thinking about. But in this case, Putnam says, the form of the initial problem was and I've often wondered if this is somehow connected to the underwear memes from South Park. I mean, the connection would have to be that those people somehow had read Putnam, which is possible. I know some South Park writers went to Harvard. I don't know. But anyway, be as it may. So this is schema 2, theory, question mark, question mark, question mark, prediction. You have to fill in the auxiliary statements that will yield the prediction. The prediction is the thing you already know, the orbit of Uranus. And so what they fill in is the auxiliary statements that there's a planet in such and such a place, blah, blah, blah. Then from that, you derive new predictions and you tell the observatory to look and there's Neptune, right? But the initial problem is like this. And this is hard for Popper to explain. Now, I mean, so like when we got our initial wrong prediction of the orbit of Uranus, we were using certain auxiliary statements. Putnam says, hey, look, Newtonian gravitation doesn't imply anything without auxiliary statements. Popper says, I always said that. These are what I call initial conditions. Putnam actually calls them boundary conditions, which is what Popper called them in German, which is what makes me think that Putnam actually has not read the whole book at this point. Because he would have at least said, oh yeah, Popper also mentions boundary conditions, but, but he doesn't even say that. So, right, this is where Popper says, well, actually, Professor Putnam, if he had read my book, would know that, right. So, right, I always said that a theory only applies basic statements given initial conditions. It forbids certain basic statements, but it doesn't imply any basic statements without initial conditions. So, however, it's not true that these auxiliary statements are exactly what Popper means by initial conditions. So the initial conditions themselves are supposed to be a basic statement. And you're supposed to test the theory by determining that the initial conditions hold and then seeing if the implied prediction actually follows. But these auxiliary statements, Putnam says, are things that number one, are not easily observable, if observable at all. Some of them are definitely not observable, like there are no other planets, right? There are no undiscovered planets. That's the classic example of a negative existential of the kind that Popper would call metaphysical, right? So, I mean, uh, um, but not only that, but many of them are false, are known to be false, right? So, in order to get the what we thought was going to be the orbit of Uranus out, and it worked for the other planets except Mercury, was well, we assume there are no other significant forces acting on the planet. I mean, we know it's false that there are no other forces, right? So, but I guess I already hedged it by saying there are no other significant forces. What you actually assume, this at least this is what Putnam says. Scientists, when they do this, don't say, well, but I think sometimes they do. Assume other forces are negligible, they might say. Putnam says for sure they don't bother to figure out exactly how strong they could be. Right? Like they don't try to nail it down. But usually, I think it's true. People often just say, assume there are no other forces, assume that the planets are moving in quote unquote a hard vacuum. I think that's just another, that just follows, or that's just a special case of there are no other forces. So I can ignore that one. But um, assume there are no undiscovered planets. So now, if the prediction is false, it seems we ought to blame the auxiliary statements and not the theory. I mean, we know the auxiliary statements, some of them we know are not true. Maybe the other forces are stronger than we thought. Maybe it's not really so much of a vacuum, which again just means there are other forces that are stronger than we thought. Maybe there's one undiscovered planet. Maybe there's lots of undiscovered planets. Maybe it's some combination of all of those, right? All of those we're going to probably think are more likely than that the theory of universal gravitation is wrong. John, you have your hand up?
Yeah, I was just thinking that like couldn't we like lump those auxiliary statements into like a part of the theory that we're testing?
But they're not a part of the theory they're testing because, again, we don't even believe them, right? There's some of them we don't even believe, whereas others, such as there are no undiscovered planets, um, we kind of guess that they might be true, uh, but they're certainly not part of the theory. They're from Popper's point of view, they're not fit to be part of a theory because they're not falsifiable and they're not strictly universal. So, and yet these are clearly also not what Popper would call initial conditions, right? There are some initial conditions in this problem, right? Like the sun and the other planets, right? Yes, we have to put those in to get predictions, but so I guess you can include those also in the auxiliary statements, but the ones that Putnam is focusing on are not fit to be initial conditions. Again, because they're not even basic statements, and we don't even think they're true. Um, so, what is Popper's response to this? Well, I mean, so first of all, he says, um, this is on page 1007. Um, that the hypothesis of Neptune was not an ad hoc hypothesis. He says Lakatos ignores the fact that almost all possible kinds of misbehavior, that is, all except a set of measure zero, that's like a technical mathematical way of saying almost none, but like one that's precise or can be made precise anyway. Uh, that is, all except a set of measure zero would not be explicable by postulating the existence of a planet P prime. Right? So first of all, the hypothesis that a single planet is causing these perturbations is it's extremely improbable in Popper's sense. It's highly falsifiable. Most observed orbits would not uh, be explainable in that way. Um, Thus, Lakatos's characteristic story is in effect an extremely exceptional case. Adams and Leverrier, I pronounce that, success in pinpointing the planet Neptune was by no means a trivial or expected success. It was a far from straightforward calculation, and the actual discovery of Neptune was a priori improbable in the extreme. Right? So that is the new hypothesis, first of all, had low inherent probability. And second of all, it made the theory more, when you add it to the theory, it became much more falsifiable because it predicted this very improbable event, namely that if you point your telescope in a certain direction at a certain time, you'll see an undiscovered planet there. Right? Like, um, that is, in the absence of the hypothesis, that's extremely improbable. With the hypothesis, it's predicted. And so the hypothesis makes the theory much more falsifiable because it implies that this very inherently improbable event will happen, and you can easily check. Um, so, I mean, Popper has more to say about that, but I think that's the core of the response, and yet it doesn't really get to especially Putnam's criticism here. It maybe does take care of, I'm not sure, maybe does take care of this aspect of Lakatos's criticism, but it doesn't really deal with Putnam's criticism here, um, which is that yes, this particular move may be okay from Popper's point of view, but the whole situation isn't what Popper tells us to expect. Right? I mean, um, because you need these very uncertain or approximate auxiliary statements to get your prediction from the theory. Um, Whatever happens, or almost whatever happens, um, whatever normal thing happens, not if the force suddenly becomes repulsive, right? But whatever normal thing happens, it's like always going to be more likely that there was something wrong with the auxiliary statements. Or Putnam also mentions this in passing, that there's another scheme, which is where the question marks go here. That is, we don't know how to derive predictions from the theory, right? This is true of a lot of the most important physical theories now, that it's very hard to derive predictions from them. Quantum chromodynamics, general relativity, right? It's very hard to get predictions out of them. Even like regular old quantum mechanics, I don't think anything more complicated than a hydrogen atom has been completely solved, right? You have to make various approximations and whatever to get an answer out. So, like, why think that those were right? You probably did something wrong. You run a huge simulation of galaxy formation and it doesn't give you the right pattern of irregularities in the microwave background. Do you say that general relativity is wrong, or do you say that your simulation probably didn't work right? So, you run a huge simulation of the weather and it doesn't predict rain at the right time. Do you say there must be unknown forces acting in the atmosphere, or do you say it's too hard to simulate? Right. So it's not clear that Popper's response, that part of Popper's response is sufficient. However, Popper does, I think, eventually, well, I say eventually, but it's actually before the other part that I just quoted. So maybe I'm guilty of something similar to what Ayer was doing. Um, Here, this is on page 98. If we do make auxiliary assumptions, and again, this is Popper's response to Putnam. Oh, I'm not sharing the screen, sorry. Come on. There we go. If we do make auxiliary assumptions, then of course we cannot be certain whether one of them, right? So right before it, he's agreed that, yeah, sometimes we have to make idealizing assumptions. If we do make auxiliary assumptions, then of course we cannot be certain whether one of them, rather than the theory under test, is responsible for any refutation. So we have to guess. Again, I think that's that's the real core of Popper's response here. Yes, it's true. Methodology doesn't tell you what to do always. Sometimes, or really always, every time, you have to guess. At some point, you take a risk and say, you know what? I know this is hard to simulate, but I think something's really wrong with Big Bang cosmology here. All simulations are giving the wrong thing. The redshifts aren't right. The high redshift galaxies are too big, and et cetera. And you start to like worry. So, um, so possibly, I think the moral is of this whole lecture is that possibly Popper actually does have a response to all these people. It's not clear. Um, um, However, on the other hand, they do all have raise an important question. Has Popper paid enough attention to what scientists actually do? Um, and, you know, you might think, and Putnam imagines Popper responding this way, right? This is on page 227. Popper might reply that he is not describing what scientists do, but what they should do. So we know that this is kind of what Popper said about methodology, right? It's not empirical science. It's not theoretical at all. It's practical in the Kantian sense. So it can't be contradicted by observations because it's not about what's true. It's about what should be true. However, as I pointed out when I first introduced that consideration before, it's not really the case that Popper can afford to not care at all about what scientists do, right? Because he's proposing this methodology because he wants to explain what makes science so successful. Um, and then draw certain morals from that, probably like political morals or whatever. So this is something I think I quoted before. He says, Lakatos asks, under what conditions did you give up your demarcation criterion? As if I had never dealt with this question. And he mentions various times he had dealt with it. Then he says, but here I can give a new reply. I shall give up my theory if Professor Lakatos succeeds in showing that Newton's theory is no more falsifiable by observable states of affairs than is Freud's. Right? So there's Popper himself saying, I do care what scientists actually do. If Newton and Einstein and Maxwell and, the heroes of science turn out not to have been doing what I say they should, then it's not a reasonable response for Popper to say, oh, I guess there is no science. So, and I'm out of time, but I guess I'll just say, it's at this point that Lakatos's most far-reaching proposal comes in, right? He says we need a meta methodology. We need to explain when we would, methodologically speaking, when would we give up our methodology? And not just leave it at saying, oh, if Newton, right? We need to explain what's going on here. And he introduces this whole apparatus of basic value judgments of scientists and whatever that is going to be used to test methodologies. Um, um, and Popper's response to that is, and Lakatos says, well, you might ask, well, when will I give up my meta methodology? And Lakatos says, well, one has to stop somewhere. Meaning it would be an infinite reguess, right? You would need a meta-meta methodology and a meta-meta-meta methodology. So Popper pounces on that and says, my demarcation criterion doesn't involve any infinite regress. I think, the issue is here, can there be is there such thing as a meta methodology at all? Or is there just one difference between theory and practice, right? And there's no appeal beyond the court of reason, right? That is, once you shift the question from what is true to what must I do, there aren't different levels of it. It's just all the same answer. You have to guess. I think that's Popper's reply. But this also, I think, helps introduce Kuhn, because I think you can notice now, what a decisive criticism would have to look like. It's not enough to bring these special cases. You have to explain what scientists are doing in general in a way that makes it clear that testing theories is not a motive for scientists, that they avoid testing theories, right? Not just that sometimes they don't treat it as a test. So none of these three people is willing to go that far, right? They all agree, oh yeah, sure, there's something called testing theories and scientists do it all the time, but you don't always treat the test result this way and blah, blah, blah. And they think that Kuhn is saying that, but we'll see that Kuhn is saying the other thing. It's much stronger. Scientists are not ever trying to test theories. So if that's true, Popper has to give up his methodology. All right. I will see you again on Zoom on Thursday. Bye.